This webcast talks about the first piece of the lab on projectile motion. So you can download this lab activity from PowerSchool page 5.1. When you download this packet, in step number 1, you'll see that there is a link to the University of Colorado simulator for projectile motion. So you can do a control click on that, and it will take you to, let's see, right here, the Projectile Motion Simulator. And we are going to just use the introductory part of this. So this picture where you see the little girl getting shot out of the cannon. Click on Intro. And here is the simulator. You can play around with it if you want. There are quite a few things that we can change. First of all, let me just fire the cannon. This red button here is the button to fire it, so I'll just fire it with the default settings. You can see that a pumpkin comes out of the cannon and it lands here. So some of the things that I can change are the initial speed of the projectile, the thing that we're firing. So I can make it go, all the way down to like 1 meter per second and all the way up to 30 meters per second. Let me make it really fast, and I'm going to fire it again. Ooh, it goes a long way. In fact, it goes out of the screen. It goes so far. And so when that happens, you can still see what's happening. See these little magnifying glass symbols up here near the top of the screen? You can zoom in and out. So I just clicked the one with the minus sign, and I've zoomed out. Now I can see that pumpkin that landed way far to the right because I fired it with a very fast speed. I don't have to fire pumpkins. I could go up here, and there's a drop down, and I can fire cannonballs or golf balls. Let's do a piano. So I'm going to fire a piano, and let's see what happens. And there comes the piano. Okay. I can raise the cannon up or down, so I can change its height. So let me lift it up really high and fire that piano again, and it goes even further. I can change the angle of the cannon. So maybe I'm going to shoot it at a 45-degree angle. Ooh, it goes way high. And I guess it's coming down, but again, it's gone out of my screen, so I may have to zoom out again. There it is. It followed this trajectory as it went around. Let's see. I can add air resistance by checking this box. So I'll fire it. This is with air resistance. The piano is not going as far because there's a drag force on it that's slowing it down. Okay. Well, anyway, so those are some of the many things that we can change. Now that we've noticed those, I'm going to click this button in the lower right-hand side of the screen. That just resets all of the defaults. So let's reset the default. And I'm going to go to the activity, and let's just see what we should do. So in step 4, it says to set these values of your constants. We're going to fire a pumpkin from a height of 10 meters. We're going to have a launch angle of 0 degrees. That means we're going to fire it horizontally, and we do not want air resistance. And in this part 1, we're trying to get information to explain how the range of the projectile, and when we say range, that's just a word that means the horizontal displacement, how far it goes horizontally. That's called range. So we're trying to see how the range, or the horizontal displacement, depends on other variables. And so our independent variable here, the thing that we're going to change in each run, is going to be the initial velocity. And while we're measuring things, we're going to measure both the range and the flight time. So you should set up a data table in Microsoft Excel. So open up Excel, and this is just a blank file, and you always put the independent variable on the left, and that's going to be the initial velocity in meters per second. let's see, I'm just going to make my column a little wider there. Okay, my first dependent variable is going to be the range, which is in meters because it's just a horizontal displacement. But while I'm taking data, I'm also going to write a second dependent variable, which is the flight time. That's the amount of time in seconds that it takes the projectile to fall to the ground. Okay, so I'm going to be measuring these things. Let me go back to the simulator here. Okay, so I have all of my constants set accurately. And so first, I'm going to change the initial speed to be 1 meter per second, and I'm going to fire that pumpkin. So it doesn't go very far, right, because it wasn't moving very fast. The way that I will measure what we're trying to measure, see these tools up here? I've got a tape measure, and then I've got, I don't know what you would call this, but this measuring device, when I bring it out, I can put that spot thing on top of the pumpkin, and then I can read off the flight time and the range. Okay, right now they both happen to be 1.43. And then I will go put those in my data table. So this was an initial velocity of 1 meter per second. It moved 1.43 meters horizontally, and it took 1.43 seconds to fall to the ground. Notice I'm not putting any units when I type the numbers. All of the units have already been described in the header. And if I want to graph this in a few minutes, Excel can only graph numbers. So everything below here in the table should just be the numbers. Don't put any letters or anything. Okay, so that was my first run. I need to get at least 10 data points. And they don't have to be in any particular order. You know, you can be somewhat random. But I'm going to increase my velocity, let's say, to 4 meters per second. And then I fire that pumpkin again. I have to move my little device over to get the new data. So when it was 4 meters per second, the range was 5.71 meters. So 4 meters per second, it was 5.71 meters. The flight time was still 1.43 seconds. So apparently changing the velocity, at least so far, it hasn't affected that flight time. Okay, so here are 2 data points. I'm going to keep measuring here. Whatever numbers you want, you can be somewhat random. But the last one that you get should be 30 meters per second, because we do want to go over this full range of speeds that they give us. So now I'm going to fire it at 30 meters per second. Ooh, it goes off the screen, so I have to use the, I have to zoom out so that I can see where it landed. And I see that if, if the initial speed was 30 meters per second, that it moved 42.84 meters, and the time was still 1.43 seconds. Okay, so get all of your data points, and then we'll go to the next webcast.